Today we'll learn the starting with the chapter 3, which is dynamics. First of the first subtopic we will go through is the force. Ladies and gentlemen, okay, a body will remain at rest or in a state of uniform motion unless it is added on by an external force. What is meant by a body? A body does mean an object that has mass. At rest means that stationary, not moving, or with zero velocity. Uniform motion means that moving with a steady speed in a right line, straight line. So, or moving with a constant velocity, or easiest, we said that not accelerating or zero acceleration. External force means that a push or pull caused by another body. So that means this statement related to which law? Okay, it's related to Newton's first law. Okay, for next slide. We notice that if there is a train moving with either constant speed, if the train moves with constant speed or accelerate or decelerate, how is the motion? Okay, so Tan Sing Hui baru masuk. Okay, now we look at here. If the train is accelerate, that means that this is view from side and view from front. What will be happen? Okay, so that means that now side view, that means always like that. So that means move left, right. That means that it will move to the side, right? So when the when the train move with constant speed, that means that the people will be in the straight position, but from the front view, okay, because the train turning corner left, right, so it will cause the man to move to left and right only. It just happens side view just have any change when there is acceleration, when accelerate or decelerate. So decelerate, it will move, okay, surf forward, but accelerate, surf, okay, backward. Next, we look at an object. When an object is applied by a force, what is the function of force? One of the function of the force is change the direction of the object. So now if I applied it with a force, that means that we see what will happen. If I change the force will change the direction and the motion of the object. Okay, by applying a force, so it will move. It will change direction, okay, and change the motion from stationary to moving. Okay, so that means that when I apply a force with opposite direction, so that means that we can stop the object. Let's go to the next statement. Next statement said that the acceleration produced by an external force acting on a body is directly proportional to the force and take place in the direction of the force. That means that the acceleration is directly proportional to the F. Then this also is inversely proportional to the mass. Which law? So this is the Newton's second law. Okay, so proportional to the force, that means that, okay, twice the force given twice the acceleration. That means that when the force increase, the acceleration also increase with the same rate. And take place means that the body accelerate in the direction of the force, and acceleration and force are both vector. Now, sorry. Okay, now we move to the next slide. Give me a few minutes, yeah, a few seconds, yeah. Weapon can't share. Okay, now, ladies and gentlemen, an external force change the momentum of a moving body, where momentum is equal to P is equal to mv. P represent momentum, mass represent the m, and velocity represent the v. This means that a body is moving with a velocity possess momentum. Newton's second law becomes the rate of change of momentum. Produce rate of change of momentum, that means that it's the force. Okay, momentum, rate of change of momentum, rate of means that something divided by the time. Rate of change of momentum, that means change of momentum divided by time. That means it is the force. Force produced by an external force, okay, acting on a body is proportional to the direction and take place in the direction of the force. Ladies and gentlemen, what will be the, okay, what is the meaning of the rate of change of momentum here? Newton's second law said that the force, you see, rate of change of momentum, it is a force. But if details for the force, actually it's referred to the resultant force. Resultant force produced by an external force. Any force which provided by other object on the body is directly proportional to the force, okay, and take place in the direction of the force. Okay, so from here, F is equal to dp over dt, momentum, change of momentum over the time. So this means that dmv over dt, both mass and force may change. Force, the force can be changed because of the change of the velocity, dvdt. That means that change of the momentum. Or it can be velocity constant, but the mass change. That means dm over dt. Okay, mv over t is the rate change of momentum, right? dv over dt, that means that ma is the force. So that means both of them represent the force. That means mv, okay, later, yeah. That means that one of the force is the force to move the body. Another force will be the external force. Okay, so that means that the total force in the system can be more than one force act on the object. Either the force can become from the m dvdt because change of the speed, change of the acceleration, or change of the momentum. That's all. Next slide. Show that. Let's say we have a rocket. We wish to launch the rocket. The rocket launched by burning the concept of the momentum, right? By burning the fuel to produce a large momentum to move the rocket. So now let's say, okay, if we look at the height, okay, how much it can move. So that means burning fuel. If I didn't burn anything, that's impossible. The rocket will launch. So now if the fuel burn is 5 kilo per second, so what happened? That means that you see nothing happened, although it's burning, because the momentum produced, okay, not enough. Not okay, the momentum produced is smaller than the momentum of the rocket. So that means after burning until all the fuel burn also can fly. So next, let's say what will happen if I use double the burning. So same, nothing happened. Okay. So nothing happened. We try to increase to 15 kg per second burning of the fuel. Okay. So we notice that the rocket moved, but after that, until certain height, so it dropped back because not enough momentum. Okay. So how about the velocity? Velocity, it moves up, accelerate, after that decelerate. That's mean in opposite direction. Okay. So mass reduce. Why? Because the burning of the fuel reduce, right? Burn of the fuel will reduce the total weight. Okay. Acceleration. Okay, that means it's accelerate. After that, none of the acceleration. Now we look at here. If we burn with 20 kg per second maximum, that means that the rocket now can move. Okay, so how about the height? The height keep on increase. Okay, until reach to the space, then the fuel burn off. If not escape the earth, the gravitational pull, that means that it will fall back to the ground. So how about the velocity? Still the same, just the amplitude, the maximum value difference, but the pattern of the graph still there. Okay, and the mass. So when the fuel burn of 20 kg fuel burn, that means that it reduced. Okay, the weight will reduce. Okay, to 200 kg, for example. Okay, initially 1,200 kg because together with the fuel. So for the acceleration, okay, it's accelerate. After that, become deceleration. Okay, so now we go to the next statement. Next statement states that when two bodies interact, the force that exert on each other are equal and opposite. So interact means that exert force to each other, on each other. Okay, so that means they have interact. That means that one and the other they exert force to each other. Exert means that cause a force to act. Equal and opposite. That means that equal is the same magnitude. Opposite means that the direction are opposite. Okay, opposite direction. Equal magnitude, opposite direction. Which law is it? Newton's which law? It is Newton's third law. The two forces are sometimes known as the action and reaction. What is meant by action? Action is doing something. Reaction, something reflect. Okay, the reflection. For example, let's say we kick a ball. Okay, don't kick a ball. We kick a coconut. Okay, we kick a coconut. So that means that my action is I apply a force to the coconut. Okay, reaction, the coconut exert an impulsive force to me. So my leg hurt. So that means that coconut reflect a force to me, impulsive force back to me. That is the reaction. Action and reaction. Action is I do something. Okay, let's say this is still using the coconut. Yeah, look at that. The coconut. I apply my leg. Okay, I apply a force of F. Okay, this is action. The coconut, when I kick, I feel pain, right? Because the coconut reflect a force to me. Where there is reaction. Okay, the more the force I provide, the more the painful of my legs. That means that the magnitude F is equal to F prime. Where the magnitude are equal, but in the opposite direction. The two forces are at the same size, same magnitude. They act in the opposite direction. They act on different objects. One leg, one coconut, for example. But they are both of the same type. Okay. So now let's move to the other slide. Ladies and gentlemen, if an object, let's say, and the moon is round to the Earth. So what happened is the concept is like this. That means that why the blue, okay, let's say the blue dot is around the red dot. Why the blue dots always around it with a constant distance? That's because there is a pulling force. Okay, attractive force exert between the red dots and the blue dots. Look at the rocket. The rocket can launch to the space because the burning of the field, the force, the momentum produced by burning of the field divided by time, momentum divided by time divided the force, right? The downward force equal to the upward force. Okay, the action, the fire will be the action. Burning of the field produce a rate of change of momentum. That's action. Reaction, the rocket move upward. And how about if a wheel is turning? When a car is moving on the ground, there will be a downward force, that is the weight of the car, and there will be a normal reaction acting on the car. Okay, when it's moving, let's look at the force. Now when it's moving, a force move forward means that there is the thrust or forward force. There will be a friction move behind and cause the car move forward. If the ground is slippy, okay, licin ya. So what happened if the wheels move without any friction force? That means that it will slippy at the same place and the car will not move. Okay, so same thing. Okay, when it's moving, okay, so it's attractive. There will be an attractive force. Okay, Earth exert a force through the moon. The moon also exert a force through the Earth. So that means that both of them are at the opposite direction but same magnitude. Okay, ladies and gentlemen, now please take out your the worksheet. Worksheet for the force. Okay, let me switch on. Okay. Siapa yang ada bagi? Okay, so that means that okay, this one okay, if you who asked this question? Lao Yongwei. Okay, Yongwei, this one okay. Any what's that, the Earth and the okay and the moon that exert a gravitational pull, gravitational attractive force. Where this force we will learn in chapter 6 or chapter 3, 4, 5, chapter 6. Okay, that is the gravitational. Okay, gravitation. So that means that don't worry. Okay, when we go through that chapter, then I will let you know why and two objects they will have an attractive force. The attractive force is because of they are in the gravitational field. Okay. Okay. Now, class, we go through the question. Okay, let me share the screen. Okay, look at the lesson 14 and Newton's law of motion. So from here, we look at here. An object of mass 5 kg is pulled by a force of 200 Newton. Calculate the acceleration of the object. Neglect the frictional force. That means assume that there's no frictional force. First, same we do the revision, yeah. Okay, so now, as we know that by using the formula, okay, FR resultant force equal to MA. Okay, so that means that M is equal to 5 kg, okay, and pulled by a force of 200 Newton. What is the acceleration? Okay, so acceleration will be equal to 40 ms negative 2. Okay, easier, right? Okay, now we move to the next question. Okay, next question. A force of 100 Newton act on an object of 10 kg as shown in the diagram. Okay, if there is no friction between the object surface, calculate the effective force and the acceleration of the object. Ladies and gentlemen, just now we said that the force, the acceleration, F is equal to ma, right? Fr equal to ma, the F must be in the direction with the object, with the movement. So this means that when we pull like that, that means F, right? The F can resolve into, okay, X component and Y component. This will be F cos 30. Okay, so the force is equal to how much? This is 100 Newton, right? So that means that in the X component, Fx is equal to F cos 30. So Fx is equal to 100 cos 30. Okay, so how much is the 100 cos 30? That will be equal to 86.6 Newton Fx. Okay, now to find the effective force Fx. Two, how about the acceleration? Fx equal to ma, because the object now, when we pull like that, the object will move in this direction, right? Okay, Fx equal to ma, that's mean at least 6.6 equal to m. M is the mass of the object. So it's 10 kg times with the acceleration. So acceleration is equal to 8.66 ms negative 2. Get it? Okay, now we go to the next question. If there is a frictional force between the surface of the object and the horizontal, calculate the magnitude of the force so that the object accelerates with a 5 ms negative 2. Now, okay, how many? 3, 4 minutes. Okay, let's say we have an object, still the same, the object. Okay, the object like that, right? Calculate the magnitude of the force so that the object accelerates. So that means that we must let the object accelerate with A equal to 5 ms negative 2. Okay, what is the magnitude of the force exerted on it? And what is the frictional force? Okay. Okay, sorry. So that means that here there will be a force of, just now, it will be the Fx, right? Fx just now is equal to 86.6 Newton. Okay, so what will be the force exerted on it? They mentioned about the force or not? They didn't mention, yeah? Okay, Now, that means that, as we know that FR resultant force is equal to MA. One. Second, FR resultant force is equal to what? That means that it will be F plus Fx minus the F, right? Okay. So that means that the force at Z. Now they want the force at Z only. Okay. They didn't mention about it. So FA, MA is equal to F plus F. So what is the magnitude? Okay, now, so that is accelerate at 5 ms negative 1. Okay, so that will be equation 2. Let me see. That means that the force at Z. That means this should be MA equal to okay. That means that they said that's what is the frictional force. Okay, the question should be like that. That means that no more F. That means that Fx minus a frictional force so that it will move with a A.